Okay, the next very powerful tool that I now want to turn to is the use of a Python interpreter, or basically giving the ability to the LLM to use and write computer programs. So instead of the LLM giving you an answer directly, it has the ability now to write a computer program and to emit special tokens that the ChatGPT application recognizes as, hey, this is not for the human. This is basically saying that whatever I outputted here is actually a computer program. Please go off and run it and give me the result of running that computer program. So it is the integration of the language model with a programming language here, like Python. So this is extremely powerful. Let's see the simplest example of where this would be used and what this would look like. So if I go to ChatGPT and I give it some kind of a multiplication problem, let's say 30 times 9 or something like that, then this is a fairly simple multiplication. And you and I can probably do something like this in our head, right? Like 30 times 9, you can just come up with the result of 270, right? So let's see what happens. Okay, so LLM did exactly what I just did. It calculated the result of the multiplication to be 270. But it's actually not really doing math. It's actually more like almost memory work, but it's easy enough to do in your head. So there was no tool use involved here. All that happened here was just the zip file doing next token prediction and gave the correct result here in its head. The problem now is, what if we want something more complicated? So what is this times this? And now, of course, this, if I asked you to calculate this, you would give up instantly because you know that you can't possibly do this in your head. And you would be looking for a calculator. And that's exactly what the LLM does now too. And OpenAI has trained ChatGPT to recognize problems that it cannot do in its head and to rely on tools instead. So what I expect ChatGPT to do for this kind of a query is to turn to tool use. So let's see what it looks like. Okay, there we go. So what's opened up here is what's called the Python interpreter. And Python is basically a little programming language. And instead of the LLM telling you directly what the result is, the LLM writes a program, and then not shown here are special tokens that tell the ChatGPT application to please run the program. And then the LLM pauses execution. Instead, the Python program runs, creates a result, and then passes this result back to the language model as text. And the language model takes over and tells you that the result of this is that. So this is tool use, incredibly powerful. And OpenAI has trained ChatGPT to kind of like know in what situations to lean on tools. And they've taught it to do that by example. So human labelers are involved in curating data sets that kind of tell the model by example in what kinds of situations it should lean on tools and how. But basically, we have a Python interpreter, and this is just an example of multiplication, but this is significantly more powerful. So let's see what we can actually do inside programming languages. Before we move on, I just wanted to make the point that unfortunately, you have to kind of keep track of which LLMs that you're talking to have different kinds of tools available to them, because different LLMs might not have all the same tools. And in particular, LLMs that do not have access to the Python interpreter or a programming language or are unwilling to use it might not give you correct results in some of these harder problems. So as an example, here we saw that ChatGPT correctly used a programming language and didn't do this in its head. Grok 3 actually, I believe, does not have access to a programming language like a Python interpreter. And here, it actually does this in its head and gets remarkably close. But if you actually look closely at it, it gets it wrong. This should be 120 instead of 060. So Grok 3 will just hallucinate through this multiplication and do it in its head and get it wrong, but actually like remarkably close. Then I tried Claude. And Claude actually wrote, in this case, not Python code, but it wrote JavaScript code. But JavaScript is also a programming language and gets the correct result. Then I came to Gemini and I asked 2.0 Pro, and Gemini did not seem to be using any tools. There's no indication of that. And yet it gave me what I think is the correct result, which actually kind of surprised me. So Gemini, I think, actually calculated this in its head correctly. And the way we can tell that this is, which is kind of incredible, the way we can tell that it's not using tools is we can just try something harder. What is, we have to make it harder for it. Okay, so it gives us some result, and then I can use my calculator here, and it's wrong, right? So this is using my MacBook Pro calculator, and it's not correct, but it's like remarkably close, but it's not correct. But it will just hallucinate the answer. So I guess like my point is, unfortunately, the state of the LLMs right now is such that different LLMs have different tools available to them, and you kind of have to keep track of it. And if they don't have the tools available, they'll just do their best, which means that they might hallucinate a result for you. So that's something to look out for. Okay, so one practical setting where this can be quite powerful is what's called ChatGPT Advanced Data Analysis. And as far as I know, this is quite unique to ChatGPT itself. And it basically gets ChatGPT to be kind of like a junior data analyst who you can kind of collaborate with. So let me show you a concrete example without going into the full detail. So first we need to get some data that we can analyze and plot and chart, etc. So here in this case, I said, let's research OpenAI valuation as an example. And I explicitly asked ChatGPT to use the search tool because I know that under the hood, such a thing exists. And I don't want it to be hallucinating data to me. I want it to actually look it up and back it up. And create a table where each year we have the valuation. So these are the OpenAI valuations over time. Notice how in 2015, it's not applicable. So the valuation is like unknown. Then I said, now plot this, use log scale for y-axis. And so this is where this gets powerful. ChatGPT goes off and writes a program that plots the data over here. So it created a little figure for us, and it sort of ran it and showed it to us. So this can be quite nice and valuable because it's a very easy way to basically collect data, upload data in a spreadsheet, visualize it, etc. I will note some of the things here. So as an example, notice that we had NA for 2015, but ChatGPT, when it was writing the code, and again, I would always encourage you to scrutinize the code, it put in 0.1 for 2015. And so basically it implicitly assumed that it made the assumption here in code that the valuation at 2015 was 100 million. And because it put in 0.1. And it kind of like did it without telling us. So it's a little bit sneaky. And that's why you kind of have to pay attention a little bit to the code. So I'm familiar with the code and I always read it. But I think I would be hesitant to potentially recommend the use of these tools if people aren't able to like read it and verify it a little bit for themselves. Now, fit a trend line and extrapolate until the year 2030. Mark the expected valuation in 2030. So it went off and it basically did a linear fit. And it's using SciPy's curve fit. And it did this and came up with a plot. And it told me that the valuation based on the trend in 2030 is approximately 1.7 trillion, which sounds amazing, except here I became suspicious because I see that ChatGPT is telling me it's 1.7 trillion. But when I look here at 2030, it's printing 20271.7b. So its extrapolation when it's printing the variable is inconsistent with 1.7 trillion. This makes it look like that valuation should be about 20 trillion. And so that's what I said, print this variable directly by itself. What is it? And then it sort of like rewrote the code and gave me the variable itself. And as we see in the label here, it is indeed 20271, etc. So in 2030, the true exponential trend extrapolation would be a valuation of 20 trillion. So I was trying to confront ChatGPT and I was like, you lied to me, right? And it's like, yeah, sorry, I messed up. So I guess I like this example because number one, it shows the power of the tool in that it can create these figures for you. And it's very nice. But I think number two, it shows the trickiness of it, where, for example, here it made an implicit assumption, and here it actually told me something, it told me just the wrong, it hallucinated 1.7 trillion. So again, it is kind of like a very, very junior data analyst. It's amazing that it can plot figures, but you have to kind of still know what this code is doing, and you have to be careful and scrutinize it and make sure that you are really watching very closely because your junior analyst is a little bit absent-minded and not quite right all the time. So really powerful, but also be careful with this. I won't go into full details of advanced data analysis, but there were many videos made on this topic. So if you would like to use some of this in your work, then I encourage you to look at some of these videos. I'm not going to go into the full detail. So a lot of promise, but be careful. Okay, so I've introduced you to ChatGPT and advanced data analysis, which is one powerful way to basically have LLMs interact with code and add some UI elements like showing of figures and things like that. I would now like to introduce you to one more related tool, and that is specific to Claude, and it's called artifacts. So let me show you by example what this is. So you have a conversation with Claude, and I'm asking, generate 20 flashcards from the following text. And for the text itself, I just came to the Adam Smith Wikipedia page, for example, and I copy-pasted this introduction here. So I copy-pasted this here and asked for flashcards, and Claude responds with 20 flashcards. So, for example, when was Adam Smith baptized? On June 16th, etc. When did he die? What was his nationality, etc. So once we have the flashcards, we actually want to practice these flashcards. And so this is where I continue the conversation and I say, now use the artifacts feature to write a flashcards app to test these flashcards. And so Claude goes off and writes code for an app that basically formats all of this into flashcards. And that looks like this. So what Claude wrote specifically was this code here. So it uses a React library and then basically creates all these components. It hard codes the Q&A into this app and then all the other functionality of it. And then the Claude interface basically is able to load these React components directly in your browser. And so you end up with an app. So when was Adam Smith baptized? And you can click to reveal the answer. And then you can say whether you got it correct or not. When did he die? What was his nationality, etc. So you can imagine doing this, and then maybe we can reset the progress or shuffle the cards, etc. So what happened here is that Claude wrote us a super duper custom app just for us right here. And typically what we're used to is some software engineers write apps, they make them available, and then they give you maybe some way to customize them or maybe to upload flashcards. Like, for example, in the Anki app, you can import flashcards and all this kind of stuff. This is a very different paradigm because in this paradigm, Claude just writes the app just for you and deploys it here in your browser. Now, keep in mind that a lot of apps you will find on the internet, they have entire backends, etc. There's none of that here. There's no database or anything like that. But these are like local apps that can run in your browser, and they can get fairly sophisticated and useful in some cases. So that's Claude Artifacts. Now, to be honest, I'm not actually a daily user of artifacts. I use it once in a while. I do know that a large number of people are experimenting with it, and you can find a lot of artifact showcases because they're easy to share. So these are a lot of things that people have developed, various timers and games and things like that. But the one use case that I did find very useful in my own work is basically the use of diagram generation. So as an example, let's go back to the book chapter of Adam Smith that we were looking at. What I do sometimes is, we are reading The Wealth of Nations by Adam Smith. I'm attaching chapter 3 and book 1. Please create a conceptual diagram of this chapter. And when Claude hears conceptual diagram of this chapter, very often it will write code that looks like this. And if you're not familiar with this, this is using the Mermaid library to basically create or define a graph. And then this is plotting that mermaid diagram. And so Claude analyzes the chapter and figures out that, okay, the key principle that's being communicated here is as follows, that basically the division of labor is related to the extent of the market, the size of it. And then these are the pieces of the chapter. So there's the comparative example of trade and how much easier it is to do on land and on water, and the specific example that's used. And that geographic factors actually make a huge difference here. And then the comparison of land transport versus water transport and how much easier water transport is. And then here we have some early civilizations that have all benefited from basically the availability of water transport and have flourished as a result of it because they support specialization. So it's, if you're a conceptual kind of like visual thinker, and I think I'm a little bit like that as well, I like to lay out information and like as like a tree like this, and it helps me remember what that chapter is about very easily. And I just really enjoy these diagrams and like kind of getting a sense of like, okay, what is the layout of the argument? How is it arranged spatially and so on? And so if you're like me, then you will definitely enjoy this. And you can make diagrams of anything, of books, of chapters, of source codes, of anything really. And so I specifically find this fairly useful. Okay, so I've shown you that LLMs are quite good at writing code. So not only can they emit code, but a lot of the apps like ChatGPT and Claude and so on have started to partially run that code in the browser. So ChatGPT will create figures and show them, and Claude artifacts will actually integrate your React component and allow you to use it right there inline in the browser. Now, actually, majority of my time personally and professionally is spent writing code. But I don't actually go to ChatGPT and ask for snippets of code because that's way too slow. ChatGPT just doesn't have the context to work with me professionally to create code. And the same goes for all the other LLMs. So instead of using features of these LLMs in the web browser, I use a specific app, and I think a lot of people in the industry do as well. And this can be multiple apps by now, VS Code, Windsurf, Cursor, etc. So I like to use Cursor currently. And this is a separate app you can get for your, for example, MacBook. And it works with the files on your file system. So this is not a this is not some kind of a web page you go to. This is a program you download, and it references the files you have on your computer, and then it works with those files and edits them with you. So the way this looks is as follows. Here I have a simple example of a React app that I built over a few minutes with Cursor. And under the hood, Cursor is using Claude 3.7 Sonnet. So under the hood, it is calling the API of Anthropic and asking Claude to do all of this stuff. But I don't have to manually go to Claude and copy paste chunks of code around. This program does that for me and has all of the context of the files in the directory and all this kind of stuff. So the app that I developed here is a very simple tic-tac-toe as an example. And Claude wrote this in probably a minute, and we can just play. X can win, or we can tie. Oh wait, sorry, I accidentally won. You can also tie. And I'd just like to show you briefly, this is a whole separate video of how you would use Cursor to be efficient. I just want you to have a sense that I started from a completely new project, and I asked the Composer app here, as it's called, the Composer feature, to basically set up a new React repository, delete a lot of the boilerplate, please make a simple tic-tac-toe app, and all of this stuff was done by Cursor. I didn't actually really do anything except for write 5 sentences. And then it changed everything and wrote all the CSS, JavaScript, etc. And then I'm running it here and hosting it locally and interacting with it in my browser. So that's Cursor. It has the context of your apps, and it's using Claude remotely through an API without having to access the web page. And a lot of people, I think, develop in this way at this time. So, and these tools have become more and more elaborate. So in the beginning, for example, you could only say change oh, Control K, please change this line of code to do this or that. And then after that, there was a Control L, Command L, which is, oh, explain this chunk of code. And you can see that there's going to be an LLM explaining this chunk of code. And what's happening under the hood is it's calling the same API that you would have access to if you actually did enter here. But this program has access to all the files, so it has all the context. And now what we're up to is not Command K and Command L. We're now up to Command I, which is this tool called Composer. And especially with the new agent integration, the Composer is like an autonomous agent on your code base. It will execute commands. It will change all the files as it needs to. It can edit across multiple files. And so you're mostly just sitting back and you're giving commands. And the name for this is called vibe coding, a name with that I think I probably minted. And vibe coding just refers to giving control to Composer and just telling it what to do and hoping that it works. Now, worst comes to worst, you can always fall back to the good old programming because we have all the files here. We can go over all the CSS and we can inspect everything. And if you're a programmer, then in principle, you can change this arbitrarily. But now you have a very helpful assistant that can do a lot of the low-level programming for you. So let's take it for a spin briefly. Let's say that when either X or O wins, I want confetti or something. And let's just see what it comes up with. Okay, I'll add a confetti effect when a player wins the game. It wants me to run React Confetti, which apparently is a library that I didn't know about. So we'll just say, okay. It installed it, and now it's going to update the app. So it's updating app.tsx, the TypeScript file, to add the confetti effect when a player wins. And it's currently writing the code, so it's generating. And we should see it in a bit. Okay, so it basically added this chunk of code, and a chunk of code here, and a chunk of code here. And then we'll also add some additional styling to make the winning cells stand out. Okay, it's still generating. Okay, and it's adding some CSS for the winning cells. So honestly, I'm not keeping full track of this. It imported React Confetti. This all seems pretty straightforward and reasonable, but I'd have to actually like really dig in. Okay, it wants to add a sound effect when a player wins, which is pretty ambitious, I think. I'm not actually 100% sure how it's going to do that, because I don't know how it gains access to a sound file like that. I don't know where it's going to get the sound file from. But every time it saves a file, we actually are deploying it. So we can actually try to refresh and just see what we have right now. So also it added a new effect. You see how it kind of like fades in, which is kind of cool. And now we'll win. Whoa, okay. Didn't actually expect that to work. This is really elaborate now. Let's play again. Whoa. Okay. Oh, I see. So it actually paused and it's waiting for me. So it wants me to confirm the command. So make public sounds. I had to confirm it explicitly. Let's create a simple audio component to play Victory sound. Sound/Victory MP3. The problem with this will be the victory.mp3 doesn't exist. So I wonder what it's going to do. It's downloading it. It wants to download it from somewhere. Let's just go along with it. Let's add a fallback in case the sound file doesn't exist. In this case, it actually does exist. And yep, we can git add. And we can basically create a git commit out of this. Okay, so the composer thinks that it is done. So let's try to take it for a spin. Okay, so yeah, pretty impressive. I don't actually know where it got the sound file from. I don't know where this URL comes from, but maybe this just appears in a lot of repositories and sort of Claude kind of like knows about it. But I'm pretty happy with this. So we can accept all, and that's it. And then we, as you can get a sense of, we could continue developing this app. And worst comes to worst, if we can't debug anything, we can always fall back to standard programming instead of